Welcome to the lesson on the Introduction to Battery Management System, abbreviated as BMS. In this lesson, we will focus on the overview of the BMS system that is responsible for monitoring, controlling, and optimizing the performance, safety, and longevity of the battery electric vehicle, BEV's, battery pack. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe the BMS. Next, you will be able to list the key functions of the BMS. Finally, you will be able to briefly describe the overview for each of the key functions of the BMS. What is a battery management system? The BMS is a crucial electronic system that's responsible for monitoring and managing the battery pack. The BMS oversees various critical functions to ensure the battery operates safely and efficiently and delivers optimal performance. The BMS is an embedded system as displayed in the image. The control modules oversee different aspects of the BEV's operation, such as the high-voltage battery performance, thermal management, and vehicle stability control. These control modules are powered by the 12V DC, abbreviated as 12-volt direct current system. The BMS performs several key functions. They include monitoring, balancing, estimation or prediction, communication, diagnostics and fault detection, and thermal management. We will look at each one of these functions in detail in the upcoming lessons. Here is a brief look at each of the key functions. Monitoring overview. The BMS continuously monitors critical parameters such as voltage, current, temperature, and the state of charge, abbreviated as SOC, of the individual cells and the entire battery. Balancing overview. The BMS plays a crucial role in maintaining the health and performance of a battery pack by ensuring that all cells within the pack are at balanced charge levels. This balancing is necessary to maximize the efficiency, capacity, and lifespan of the battery. Balancing can be achieved by the process of active and passive balancing. Active balancing involves redistributing energy among the cells to equalize their charge levels. Passive balancing involves dissipating excess energy from overcharged cells as heat. Estimation prediction overview. The BMS performs estimation or prediction functions to provide accurate information about the battery's status and performance. The BMS is responsible for estimating the following key parameters: state of health, abbreviated as SOH, state of charge, abbreviated as SOC, state of power, abbreviated as SOP, and state of life, abbreviated as SOL. Communication overview. In the BMS, effective communication is essential for ensuring safe and efficient operation. The communication protocols, namely the Controller Area Network, abbreviated as CAN, Local Internet Network, abbreviated as LIN, and Ethernet, are employed to facilitate data exchange between the BMS and the other vehicle components. Diagnostics/fault detection overview. One of the primary roles of the BMS is to perform diagnostics and fault detection to ensure battery safety and performance. Thermal management overview. The BMS and thermal management system, abbreviated as TMS, are closely integrated to maintain the battery pack's temperature within a safe and efficient operating range. Let us now look at the lesson summary on the Introduction to BMS. The BMS is a crucial embedded electronic system that monitors and manages the battery pack to ensure safe, efficient, and optimal performance. BMS control modules and oversees key functions such as high-voltage battery performance, thermal management, and vehicle stability, powered by the 12-volt direct current system. The key BMS functions include monitoring, balancing, estimation prediction, communication, diagnostics, fault detection, and thermal management. Thank you.